Have you ever wondered if all the particles in the universe are just tiny strings doing a cosmic jig? Now that is the most important idea behind string theory. But this theory is about more than just how particles move along strings. It tries to figure out why our universe has all the laws and constants that it does. Unfortunately, the idea has been criticized and sometimes mistaken as a tale of how the world came to be. Now, if you really want to know what string theory actually is, you are in luck. Watch the whole video to find out what is really behind this crazy idea. Humans have always been curious about the true nature of the universe. The more we learn, the more bizarre and complex our stories become. Some of them are so hard to understand that it is hard to figure out what they are about. For example, quantum physics. Now, when we look more deeply into reality, we find amazing things. We see beautiful scenery in the tiniest bits of dust, zoos full of strange animals, and complex robots made of protein. All of these are made up of structures called molecules, which are made up of even smaller parts called atoms. We used to think that atoms were the most important parts of reality. That is, until we smashed them together with a lot of force and found basic particles, which are so small that they cannot be broken apart. Since particles are so small, electromagnetic waves, which we usually use to see things, are too big to touch them. It is like trying to give a high five to a gnat with a huge foam hand. You will just miss it. We can try to make waves with super short wavelengths to get down to the particle level. But there is a catch. More wavelengths mean more energy. And when we use high energy waves to touch a particle, we change it. So when we try to look at a particle, we change it unknowingly. What does an elementary particle really look like? What's its true nature? Here's the twist. We don't have a definitive answer. So what do we clever humans do when faced with such a dilemma? We come up with a workaround, a sort of mathematical fiction. This fiction helps us define these particles and calculate how they interact with one another. We call this framework quantum field theory. And let me tell you, it's been a game changer. But gravity makes things a little more complicated. In the world of quantum physics, specific particles carry every physical force. But Einstein's theory of general relativity says that gravity is not just another force. Instead, it is more like the stage on which the story of the universe plays out. If we could somehow marry gravity with quantum physics and the standard model, we have ourselves the holy grail, the theory of everything. So some brilliant minds put on their thinking caps and came up with a fresh narrative. They asked themselves, what's more complex than a point? The answer? A line, or better yet, a string. And just like that, string theory was born. As these basic strings twist, fold, and vibrate, they make matter, energy, and all kinds of things like gravity and electricity. Now, let us dive into the strange history of string theory, which began with a fortunate accident. Imagine this. In 1969, an Italian physicist named Gabriele Veneziano was trying to figure out how particles like protons and neutrons behave and discovered string theory. It's like searching for your lost car keys and discovering a hidden treasure chest instead. Veneziano was actually working on equations to describe how these particles interacted with each other. But as he crunched the numbers, something unexpected popped up. The equations didn't match particles. They seemed to describe something entirely new, tiny vibrating strings. These weren't irregular strings. They were like super tiny strings on a musical instrument. And they had the potential to change our whole understanding of the universe. After a significant amount of time has passed, scientists from all over the world jump on the bandwagon of string theory and attempt to determine what the meaning of this accidental discovery is. A few brilliant ideas that were proposed in the 1970s, 1980s, and 1990s was responsible for the string theory's gradual improvement over the following half-century. Today, it is a very active field, and a large number of specialists are exerting a lot of effort to find out what is going on. But has string theory ever passed a test of the universe? Nope, says the universe. No experiment has given string theory a perfect score, proving that it is the theory that ties everything together. But before you call it a failure of the universe, understand that science is a game of patience. Einstein predicted gravitational waves in 1915, but they were not actually seen until 2015. So who knows what will happen with string theory in the future? But here's where things start to get strange. String theory suggests a massive 10 dimensions, but we humans live in a nice 4-dimensional world, with 3 space dimensions and 1 time dimension. Do not worry though, string theory has a plan. It hides those extra 6 dimensions from our senses by folding them up like a small map. Only a very massive and precise experiment, such as CERN's Massive Hadron Collider, would be able to detect these shrunken dimensions. What's so intriguing about string theory is its elegance. It paints a picture where various elementary particles are like different tunes played by vibrating strings. Think of it as a violin string producing various notes based on how it vibrates. Well, a string can do the same for particles. And the best part, it doesn't leave out gravity. String theory boldly says that it will bring together all of the basic forces of the world. This caused a lot of buzz and excitement. String theory seemed like the golden ticket to a theory of everything. But there's always a but in science. It came with a lot of baggage. The math that makes string theory tick doesn't quite fit into our universe with its 3-space and 1-time dimension. So what did the smart people who studied string theory do? They did math and model worlds and then tried to figure out how to fit those extra 6 dimensions into our own universe. No one has been able to solve the cosmic code yet, despite their best efforts, and none of string theory's predictions have been proven right by experiments in the real world. Some people might say that a theory is not really scientific if it cannot make claims that can be tested. After all, science is all about trying things out and making predictions. Then why bother with strings at all? Now things start to get interesting. Math is the building block of science. It is like the global language. No matter how you look at it, 2 plus 2 always makes 4. Mathematically, string theory makes sense. Because of this, it is still useful. Think of it this way. If you wanted to build a huge cruise ship but only had plans for a small rowboat, you could still use those rowboat plans. There are some changes, like the engine, the materials, and the size, but they both float in the same way. If you look at the plans for the rowboat, you might finally learn how to build that cruise ship. With string theory, we do not want to find a final answer about how the world works. But like the point particle idea we talked about earlier, it is a useful tool. It helps theoretical scientists learn more about the mysteries of quantum physics and the beauty of math. So in a way, string theory is not about trying to find the best explanation for everything. It is about how to use strings as a way to figure out how the quantum world works. We still do not know what reality is really like, but we will keep making up stories and asking questions, and maybe one day we will figure out what is going on in the universe. Could there be more dimensions out there? What are your thoughts on this tantalizing theory? Share your insights in the comments below. And if you're as fascinated by the mysteries of the cosmos as we are, don't forget to hit that subscribe button. Stay tuned for more mind-expanding journeys through the universe.